Not that one. I want that one. So 13. Did you leave it in radians or just change it to degrees? Okay. So what's pi over 5 radians in degrees? Since you did that. What did you get? Okay. Ah. Some of you ignore me. Whatever homework I am getting is mostly answers. That's why there's lots of blanks on the test. There'll be a lot of people retaking that first test. I hope that you'll change your ways and you'll actually put more time and effort into the homework instead of just taking a whole weekend off. Pi over 5 radians is how many degrees? I mean, this is simple stuff. We should be able to do this, right? 36 degrees, right? 180 over 5, right? 36 degrees. Okay, so what's pi over 2 in terms, if you wanted to change this in 2 degrees, sorry, how many degrees is that? Hey, thank you for telling me that. Okay, so do you think that this pattern is set up as a sine or a cosine? See, it says sine, cosine, sine, cosine. Which one is it? That is a sine, right? And it has something to do with 36 and 90. Question is, are we going to add them or are we going to subtract them? Add them, right? Because sine keeps the same sign, as we said over and over again. So this is the sine of what angle? 126. I guess I don't need parentheses. Sine of 126 degrees. It did not ask me to actually find it, folks. They asked me to write as a sine, a cosine, or a tangent. So, what did you pick on 15? Did you pick a sine, a cosine, or a tangent? Oh, I hope you said tangent. Yes. There's a whole lot of clues there that might tell you that. Okay, so tangent, right? Did you say something about 19 and 47? Did you decide you were going to add them or subtract them? Add? How did you decide that? Because the top is based on the sine and the bottom is based on cosine, the sign on the top stays the same, right? Okay, so that's tangent of what? 66, right? Don't say that around the clones, man. Phew. Oh, yeah. Yep. No, that's fine. Now, did they tell me where I'm headed? Because I don't think I have. All right. I'll look on my email.
So I'm here until 11:59.
All right. Hopefully back sooner than that. I need you to keep working on homework. Some of you I know haven't started. So this would be a good time for you to start working on problems and find ones that I can help you with. I hope this will be a quick meeting for me to run to, come back and answer more questions for you. Tan 66 is the answer to the question. Well, you really need to pay attention to the fact that there's one sine and one cosine. That's really the thing that you need to pay attention to. And then you can, look back at your formula sheet and go, okay, let's see here. Where? Come on. You can go back and look at the sine formula and see that the first term starts out with that sine u cosine v, so that it's got a mixture of the two. Okay? Whereas cosine starts out, both of them cosine u, cosine v. All right? So That's how I can tell when I look at question 11. That we're dealing with a sine. And then, of course, once I decide that, then I know that I'm dealing with 42 and 17, and I just have to say, do I keep the sign or do I change it? You keep it. Sine keeps the same sign. So my answer to the question is sine. Let's see. 32 take away 7. What are we at, 25? So, anything past this section into some of these other ones? Some of those look the same. Although if you want me to do any of those, I can. Yes. 35 and 37. Sure thing. Use sum or difference identities, not your grapher, to solve the equation exactly. Okay. I definitely think 35 is going to be a handful. We'll see. So when I see question 35, I need to deal with that, and I need to deal with that. I'm going to make a replacement. So, what can we replace? Wait a sec. Have we seen that formula yet? Did you guys do identities? I guess I should ask. Maybe I should scroll back and look for myself. No, you just did those. Okay, so. All right. I guess we got to do this the hard way. I promise you this would look a lot nicer than it's going to look here in a second, okay? Because this right here is going to get replaced with sine of x plus x. Do you see how x plus x is equal to 2x? Okay. And then, of course, there's a cosine x next to that part. Okay, so what are we going to replace that sine x plus x with? Sine, the formula for that would be sine x cosine x plus cosine x sine x. All right, all I'm doing is using that formula that we just looked at to replace this. And of course, that thing's getting multiplied by cosine x. Mind you, this is only the one side of the equation so far. Are those two terms alike? Are these two terms alike? Yeah, they're alike. So how many do we have? 2. Now, what you just basically told me was an identity. You should probably write this down. Okay? Sine 2x is equal to 2 sine x cosine x. That's an identity. That's an important one. Sine 2x equals 2 sine x cosine x. In fact, that's coming in section 5.4. So they're kind of giving you a preview of what you're going to see in 5.4. Of course, then we have this cosine x right here. And what do you get when you multiply cosine x times cosine x? Cosine squared x. So, folks, you and I just literally did the left side of the equal sign. That's all we've done. Okay, everybody got that written down somewhere? Because I'm probably going to have to erase. Okay, I'll erase and we'll do the other side. But I'll write that down. 2 sine x. 2 sine x cosine squared x. Okay, so that's this. Okay, now for the other side of the equal sign. What do you think we should replace the... Well, so now we're going to do cosine of x plus x times sine x. Cosine, cosine. Sine, sine. Man, I'm running out of room here. What goes in the middle there? Ah, good call. Minus, because cosine flips. And I ran out of room. I'll write the other sine x that was supposed to be on the outside of the parentheses there. Okay, so what is cosine times cosine more often referred to as? Cosine squared. And we have minus sine x times sine x. That would be minus sine squared x. Now, what you just showed, this equals this, that's another one of those cool identities you're going to learn about in section 5.4. And then, of course, this particular problem has an extra sine x on the outside. So, of course, doing our algebra, we'll move that here, and that would be cosine squared x sine x minus what? What do you get when you take sine squared times sine? Sine cubed, good. Sine cubed x. Hopefully you have all that written down, because I'm going to erase here, at least part of the screen, and copy the blue part down up at the top. Here, I'll at least erase this part right here, and that'll give me enough room to copy what we have down there. Cosine squared x sine x minus sine cubed x. Everybody got what they need copied down? And I hope it's a lot. Give myself some space. What do you notice about these two things that I'm circling in the black? What do you notice about them? They both have a cosine squared, and they both have sine. Are those like terms? Okay, let me write it maybe the way you might have seen it in algebra 2. Okay? What if I wrote 2xy squared, but over here on this side I had y squared x? Are those two things like terms? Yes, they are like terms. They have exactly the same variables with exactly the same exponents. Those are like terms. Just because the other one kind of got a little rearranged does not matter. They're like terms. So what do we do with like terms when we're solving? You combine them. So let's push everything. Well, let's at least push these terms. Let's push this term to the other side. Would we be adding it or subtracting it? We would subtract it. And so basically you have two of them on the left side and you're taking away one of them. So that means you would be left with one of them. Sine x cosine squared x equals negative sine cubed x. In fact, maybe we should have just pushed everything to one side, because we know in these solving situations that we're going to look for ways to factor. So just what are we going to do with that term to move it to the other side? We're going to add it. So we have sine x cosine squared x plus sine cubed x equals 0. Folks, I am not going to put a question this complicated on a test. Every question I put on that last test was simple. And I looked over and analyzed them to really find out, were there any difficult ones? No, there weren't. So If you're not getting homework accomplished, then that's really causing a problem. But there's no way I'd put a question like this. It's got way too many steps on it. All right, now we got to factor this thing. What do you see that you can pull out of both of these terms? You cannot take a cosine x out of both of those terms that are underlined in the blue. They both have a sine x that you can pull out. So if we pull the sine x out, what are we left with? Cosine squared x plus sine squared x. That's 1? Oh my goodness, that's so nice. Sine x times 1 equals 0. Okay. Can you tell me, is sine an x value, a y value, or a slope? It's a y value, right? So think back to your unit circle. Where do you have a y value that's equal to 1? Pi over 2. That is the only answer to this question. Pi over 2. Right there at the top. So I'll squeeze my answer in here right at the bottom here. That's got a lot of good stuff in it, because in that problem we had to substitute with the sine x plus x. We had to substitute with the cosine x plus x. We had to distribute a whole lot of stuff. We had to add like terms. We had to shift everything over to one side and factor. That's a lot of stuff in one question. That's why that's not going to appear as a test question. Now, parts of that can. Smaller parts of that can definitely appear as test questions, but not that big. That's ugly. Plus, I would have in the next section, we would have a nicer formula to substitute for you. So it would be easier. It would look easier, I should say. At least not quite as ugly. Now, don't you get the idea in your brain, oh, hey, man, I could just look at my formula sheet. I see this one on the formula sheet. The answer, oh, I'm done. You're not done, folks, just because that one's on the formula sheet. Remember, this says proof. So what do you think we should do with this side? Because remember, we're trying to move this to the right side. We need to use what formula to replace it? The sign of a difference, right? So set that up. Go back to that formula in your notes. Set it up. You got to use pi over 2's and u's. Okay? Write it down. Go back to the formula. Should be in your notes. Sine keeps the same sign, right? So there should be a minus in between. Go back to your notes and find that formula. You do. There's your cosine one. Where's your sine? Go ahead. You took the notes. Oh, okay, all right. So cosine was first. The sine's next. Yeah, well, if you want to just kind of go forward, know where your place is right now, where your time is. You just get, oh, that's right. Yeah, no, you're right.
Is you?
Find it.
I'm trying to look through my notes before I do it.
So the sine formula, there's the cosine one you wrote down.
Did I not write down that one?
Because, I mean, we did the notes on it. Somewhere. That one right there. Yeah, you definitely want that in your notes. What's the sine of pi over 2? It's a 1, isn't it? Oops. So we know what to substitute that with. What's the cosine of pi over 2? 0. Now what? Over here? Gone. Cosine u is the answer. You knew that was the answer because that's the end of the proof. But if you're not going to show me those steps, don't expect that that'll, give you credit. Any questions on what we did there? We used the formula, we set it up, substituted in what we knew. Whole lot easier than 35 was. Got another one? 30 what? 39. Cotangent pi over 2 minus u is the same thing as what? 1 over tangent pi over 2 minus u. I think you should focus your attention on the denominator, figure that part out, and then when you get that, what are you going to do with it? What does it mean when we say 1 over something? We want the reciprocal. So you figure out what tangent pi over 2 minus u is, and yes, you'll go back to that tangent formula, right? And you'll plug everything in you know, and some of them will have tangent pi over 2's. And what's the tangent of pi over 2? Oh, that's going to be the undefined one, isn't it?
Yes.
Yeah, we would have to go back to the sines and the cosines. And as I said to you in class, I'm not interested in going backwards. We could, but I would rather be focused on the ones using the simplified tangent formula, so I'm not going to have something like this with the pi over 2's in it. I'll get some lunch. Okay, so we're looking at question 5. I told you you could convert that into degrees, so if you don't know how to do this or you didn't do this, you should be doing it now. What is pi over 12 in degrees? Yeah, oh yeah. Yeah. Some people are just not comfortable. Yeah. 15 degrees, right? So this is the cosine of 15 degrees. Now, if you like dealing with radians and you want to just stay with radians, it's completely fine to do that. Okay? Not a lot of you like that. So that's why I said I was willing to allow you to switch it to degrees. So we want to do something with, can you think of a way to come up with 15 degrees using 30s, 45s, 60s, 90s, something? 45 minus 30 would work. Let's suppose you did it this way and your neighbor did 60 minus 45. Would it still work? Yes, it would. You'd get the same answer. So the cosine formula, that would be, let's see if I can zoom that out and get some a little bit more space here. According to your notes, wasn't that cosine, and then sine, and I'm running out of room here, so sine. What goes in between? Okay, I need to decide based on the fact that I'm dealing with cosine and it's subtraction, 45 minus 30. It is addition, right? Because sine keeps the same sign. The other one does not. Okay, so what's the cosine of 45? I'm hoping this hasn't disappeared from your brain, seriously. Radical 2 over 2, thank you very much. All right, hopefully you're able to go back, think about your 45, what the x value is, radical 2 over 2, and how about the cosine of 30? Cosine of 30 is radical 3 over 2, yeah, closer to the outside edge. And then we have sine 45, radical 2 over 2, and the sine of 30, 1/2. Okay, show me your answer if you've already done it, and if not, then I'll be happy to. Cosine 60. Okay, so cosine 60, that would be the x value for 60 degrees. That would be your 1/2. Come straight down, it's 1/2 for your x value. That's why I draw the circle each time, just to kind of remind you. Correct. Oh, no. 15. Right. So 12 goes into 18. 6 left over. 60. 12 goes into 65. So I don't know why you have that extra 0 against John, and she's up to me now. So it'd be 1 over 5.
Yeah, it needs to be open.
Yeah, you're as good as it gets right there. Show me what you got. Good answer. I like it. No, you cannot. That's a good answer right there. Yep. I don't care if you combine it or leave it apart like that. See what you get. Radical 2 on top. 4 on top, right? Times 2 is 4. What you get for that? Yep. Plus. That's on the bottom of that. That's correct. And that Now you're correct. One should have 2 denominators before.
Did you dream about that?
Yes. I would accept that as final answer. That is
I'll take this over there.
Yeah.
If we're putting this back here, we can go to the
Yes. So I'm hoping that you said radical 6 over 4 plus radical 2 over 4. Could you write that radical 6 plus radical 2 all over 4? Is that the same thing? Yes, it is. I wouldn't care which one you wrote. Now, don't be the person that says radical 8. We cannot add unlike radicals. What can we do with unlike radicals? Because you just did it. We can multiply them, but then don't take that and think you can do it with everything. It's true for multiplication. It's not true for addition. You have to have like terms to be able to add radicals. Okay, anything else in that range right there? So are we good with all the odds in there? Oh, yes. 15? Sure. Okay, folks, you have to decide whether you think this is a sine, a cosine, or a tangent. Are there any good clues? Tangent, nice job. Yes. Okay, so that wasn't too hard to figure out it was a tangent. And we're doing something with 19 and 47. How do you know we're adding them? Pay attention to the top. Because the top of a tangent is the sine function. And the sine function keeps the same sign. So that is telling me that this should be addition. So, do not quote this one to any of the clone troopers. Come on, what's 19 plus 47? Don't quote that to a clone trooper. Okay? Sorry. Special Order 66, they all went crazy. Remember that? Okay. It's been a while. They all turned into the stormtroopers.
Special Order 66? You just mean Order 66?
No, they said something about, he made some sort of reference to, and I don't remember, I might be using the wrong term, but he said something about, I thought it was something Order 66.
Execute Order 66.
Oh, maybe he said that.
Yeah.
Maybe that's it. Maybe that's. I thought there was something in front of that, but maybe that's it. Okay, 13. What's pi over 5 in degrees? Yes? Okay, I'll clear this out for a second and come back to it for those of you who are curious. Okay, when we dealt with a tangent, okay, just look at that formula. Do you see the word tangent written a few times? Okay, so what they were asking me to do for this question is they were saying, they gave me the right side. Sorry, let me lock that in place. They gave me this side, and they're forcing me to go backwards. So I had to look at what they gave me and analyze it and go, okay, it's a tangent, and we're taking the 19 and the 47 and we're adding them together because we paid attention to that top sign and replaced it over there. So it really wasn't, we didn't need to do anything with the denominator because we had enough clues from the numerator that we could get to the tangent 66. And I'm probably going to have to redo that. So pi over 5, what'd you find out? Pi over 5 is what? Some of you do not have the luxury of being able to ignore what's going on, even though you do. What is pi over 5? Okay, by this time of your mathematical career, since we have done this a bunch of times, can you just imagine a number that you should replace this pi with? Is there a number that's equivalent to pi that you could just put in that place? How about 180? So you really literally could just take 180 and divide by 5. Because if you haven't noticed, every time we've done this, the pi's and the radians have canceled out. Remember that? Okay, so it literally becomes a substitution. Now, the reason we can't always do that is, what if I tried to trick you and I asked you about 4 radians? Well, now we're getting into decimal versions of radians. Are you paying attention? Because it doesn't seem like it. It's really annoying. So that becomes sine 25. And I believe I didn't have this ring recorded, but this one ended up being 36 plus 90, or sine 126. Okay, let's move on to something more challenging. Now that we understand that. Anything in this range you want to go through? Any of the odds that I've assigned to you in here? 21? And maybe I better back up and make sure. Oh, these are the same exact type of questions as 11 through 15. Okay, well, that makes more sense. Okay. Do you think it's a sine? Do you think it's a cosine? Or do you think it's a tangent? Yep, good call. It's a tangent. So the two things we're dealing with are 2y and 3x. I guess your only decision left is to figure out what goes in between. Yep, it's the one on the bottom there, plus. So, hey, we're done. So it's a very similar thing to what you were doing before. You just have expressions instead of numbers to put in. Okay. Any of these identities down here? Any of the odd identities down there? Yes, sir. 23? Sure. So we're going to use the sine formula of a difference. And so the sine formula says sine of the first, cosine of the second, cosine of the first, sine of the second. And what goes in between? What goes in between, since I see a minus right there? A minus. Okay, you show me what's next.
You should be able to do some substitutions that answer the question. If you've already done it, just show me your work or point to it and I'll look at what you've done. You haven't, I'll just what are you substituting in there? So sine is a y value, right? So sine is the y value at the top, so it's a 1, right? Yeah. And then what are you going to put in for cosine? Yeah. That's why things start disappearing. Think about what cosine times 2 is. Sine of 90 is at the top of the circle, right? So find values, top of the circle that you can use. Wait, why would this one? Because goes in. Because this is cosine pi over 2. Yes, keeping sine x because I don't know what that is. What are you replacing? How do you over it? I need to know what the cosine of pi over 2 is. So that's where you need to look at your unit circle and think about where pi over 2 is, and think about the cosine and the sine. Oh, yes. So what's the sine of pi over 2? And that negative doesn't disappear. Sine is the y value, and it's the top of the circle. Correct. So where's your pi over 2? The top of the circle, right? The very top. So what do you got for the cosine at the top of the circle? That's actually the sine. That's the y value. Cosine is the x value.
What did you put in the place of cosine pi over 2? 0. Good call. The x value at the top of the circle is 0.
You are the last kid I should forget a first name for since I have a daughter named
You're welcome. When you replace that with 0, what happens to this term? It becomes 0. It's gone. It disappears. Now over here we have negative cosine x. What did you replace sine pi over 2 with? That's a 1. So negative cosine x is your answer. We knew that was going to happen because they told me it would. You have to be able to use the sum or difference formula, in this case the difference formula, and follow the formula, plug things in, look for substitutions, and some wonderful things happen. Any other questions on that one? Any others on this page or this section right here?
Can you do
29,
29?
sure. So tangent theta plus pi over 4. Okay, so now I've got to think about, so that's tangent theta. Keep the same sign on top. Tangent pi over 4. Okay. On the bottom, we have 1. Switch the sign. Tangent theta. Tangent pi over 4. All I'm doing is plugging things into the formula, folks. Okay. You start substituting. See if you can make it happen. See if you can see the algebra.
cosine formula. Pi over 2 is at the top. Pi over 4 has to be in quadrant 1. Now, if you don't remember what pi over 4 is, convert it to a degree measure, because I'm pretty sure if you convert it to a degree measure, it would probably be nothing like versus. And then you want the slope of that. That would be smack dab in the middle. So what's the slope of the line? It's the really nice one. It's a really nice one. So it's right smack dab. The street origins, it's perfectly 45, 90. These, the ones that are exactly the same. So if you take y and divide it by the average, they're the same. Not subtracting. Not subtracting. You should take like this is 5, this is 5. You can get a even now that shows. That's the rows make you think about the number 1 and think, oh wow, that makes sense now. Because right here, for the resin 1, plus tangent theta, and if I replace that with a 1, we would have exactly what we needed on top. That make sense?
What did you replace tangent pi over 4 with? What did you replace tangent pi over 4 with? 1. The slope at pi over 4, folks, if you think about that circle, pi over 4 is smack dab in the middle there. That's got a slope of 1. It's not the x value or the y value, it's the slope. So if you did that replacement, don't you have your proof? We're done. I mean, it really doesn't matter if you rearrange it in the numerator. It's the same thing. That's not true. Okay, that denominator cannot be changed to plain old negative tan theta. It's 1 minus tan theta. No, it's the times 1. I just was showing that because I wanted people to see what we were substituting. But you're right. Multiplying by 1 is not changing anything. Okay. Can I do what? Oh, that wasn't a question for me, evidently. Okay, question 35. I recorded it during 5th period. It's long. It is not a test-worthy question because there are so many parts to it. Please watch the video once I get it posted on question 35, okay? It has lots of good parts to it, but it is not something, I'm never going to give you that question to solve on a test. Too many parts, too many places for mistakes. Okay, in fact, I looked through your last test to see if I, based upon some of the things I was getting, whether I made the test questions too hard. And I really picked kind of nice ones. Because there were just a few substitutions you needed to do on each one, and you had it. We just didn't know what to substitute, and that's what caused the problems. How about we do question 40? Secant. What's that one? What does it go with? Cosine. So we know that this is 1 over cosine pi over 2 minus u. I want you right now to focus your attention on this part. The part that I circled in the green. That's what you need to work on. Once you find it, what is the last step we will do?
What does it mean when we say 1 over something? Reciprocal, right? So once, and you're dancing around the right answer there, but once we find whatever that thing is in the green, I don't want that. I want the reciprocal of it. Okay? So use your formula. Go back to the cosine formula that's in your notes from section 5.3. Start writing it out. Go back to your cosine. Cosine, right? According to that box, right? Cosine. Sine. Do you have that formula written somewhere? Okay. Yeah, you'll have to, it'll be on the formula sheet, but you'll have to have that formula to look at to be able to write it out. Oh, yeah.
Whatever you did in cosine.
I don't care about that whatsoever. Alright? No, that's the tangent one. I need the cosine one. One that's in your notes in 5.3. You go back here, you'll.
I think I don't honestly have
Sine it. That's the sine.
I have whatever cosine.
Did you find the formula? What's it look like? Amstutz, did you find the formula? Okay. Do you have your 5.3 notes out? Come on.
Using your cosine formula.
Cosine. Sine. What should I put in the middle? What should I put in the middle? What? We're dealing with cosine. I need to know whether it's a positive or negative that goes in here. It's a difference. So that's addition. Thank you. So what'd you put here? Cosine pi over 2. 0, right? What'd you put in there for sine pi over 2? 1. Okay.
Finish the proof. If you know those substitutions. Okay, now that is great, but you're one step away from getting the right answer. I mean, you are right there at the end. All we need is one more step. What is 1 over sine mu equal? Cosecant. Yep. That is the end of the proof. right here, 0.
I hope you realize that those terms disappeared, and all you're left with is 1 over sine u. If you leave this, you are not done with the proof. What is the last step? What is 1 over sine u equal to? Cosecant u. And that was what you needed to show me, because that's what they even told you it was supposed to equal. So just because you got to 1 over sine u, which I'm very happy that you did, doesn't mean that you got to the end of the proof. It means you stopped one step shy of finishing. Okay, let's do 42. Okay, set up your cosine formula. Set up your cosine formula of the sum and watch what happens. See if you can understand why things are changing the way they are, what you should replace. Yes, very annoying. Yep, exactly. Yep, you're just taking those two, setting them right in there. So we're using that cosine formula. We gotta do set our x and our pi over 2 in. It's not in, it's in 5-3. So right in here. This is formula we're using because it's cosine of the sum or difference. So you're taking that, and this is your u, this is your v, and this is what it is. Cosine x, cosine pi over 2. What goes in between? Negative sine x, sine pi over 2. What did you replace cosine pi over 2 with? 0. You need to be able to show me this kind of work. You need to be able to show me that you're left with only negative sine x. We'll start section 5-4 tomorrow.